Hi, my name is Paco Nathan. I'm with O'Reilly Media, and I have the pleasure of talking today with Jay Jenkins, Head of Customer Engineering in Southeast Asia at Google Cloud Platform. And looking forward to the topics here about Google Cloud Platform. Welcome, Jay.
Thank you very much.
So can you tell us in general, just what are you all doing with Google Cloud Platform? How long has this been around?
Sure. So, Google Cloud has actually been around for 18 years, right? I think if you think about the products that we've created, Google Search itself, you could consider sort of a software as a service, right? Where essentially you're putting in 3 words, it's looking across trillions of websites and trying to provide you an answer very quickly. And we were sort of born there. And along the way, we actually developed a lot of technologies, and a lot of that came through via open research. So, for instance, our MapReduce paper, right, which led to things like Hadoop. But all these other technologies we needed to build in order to build search, but also to build 7 other products, right? So we've got 7 products with over 1 billion users, right? 2 billion users on Android. We've got YouTube, which delivers 1 billion hours of video every single day. So that's 114,000 years for an individual person to watch, and that's a lot of data. And we ran into a lot of problems ourselves, in order to deliver those services, we had to create a lot of products internally. And what we're doing actually with Google Cloud is we're actually exposing a lot of those products that we use internally to our customers. So now Google Cloud itself serves our customers' billion users as well.
Well, I can imagine that along with the technologies and the internal products, there's also just a lot of learnings, a lot of practice that has gone in over this period, 2 decades.
Yeah, absolutely, right. And one of the problems we had was not only in scaling our infrastructure, but also scaling our operations, right? So, and really in order to scale our operations, or really how we had to make it so we weren't scaling our operations at the same time we were scaling our infrastructure, we really had to invent a lot of these technologies. And I think for us, what was true then was, that Google was really one of the only companies that were having these sorts of big data problems. But that's not true today, right? A lot of companies have exactly the same problems and different problems. And the faster we can get a lot of the technologies we're using to the market, the more that everybody can leverage those.
Excellent. Well, in these customer engagements then I imagine there's a lot of education as well, people needing to learn how to use the tooling that's available, what are best practices, et cetera. Is that more of what your team is doing day to day?
Yeah, so that's exactly what our jobs are as customer engineers. It's working with our customers, finding out what their current solutions are, which they might want to migrate, or taking a look at what new solutions they might want to build and see how they might want to architect those. And the cloud can be treated differently, right? Because you're not actually purchasing the infrastructure, and if you treat the cloud the same way as you're treating your on-premise infrastructure, you're not going to get a lot of the benefits that the cloud can provide, right? The ability to not only to scale up, but to also scale back down quickly when you need to.
Interesting. Now, Google is famous for work with machine learning and AI, of course. What types of machine learning services are being rolled out for businesses to take advantage?
Yeah, absolutely. So I think one of the biggest things that we've released in the past couple of years, so actually 2 years ago, we released TensorFlow. It's currently on version 1.4, and it is a machine learning framework that essentially uses data flow graphs in order to do machine learning. So customers can take their data, create their recipe, and get their answers out of that. In addition to that, and in order to support that, we also have TPUs, which we've created as well.
Yes.
Right, so a couple of years ago, and we created TPUs. We've been using those internally for a long time, and in May we then iterated on that and created version 2, which actually not only does the inference really well, but also does the training really well, and we're going to make those available to cloud customers soon as well.
So that'll be part of the cloud instances that you
That's right.
use?
So besides the normal CPUs you can use, the GPUs of course that you can use, which a lot of people are using for machine learning today, they'll also be able to use TPUs.
One of the themes that we're seeing out of the conferences here is that hardware is evolving rapidly and in many different ways. So we hear about what's going on with very interesting processors, TPUs, GPUs in the cloud, et cetera. But also I think that there's interesting work with interconnects and just leveraging, again, sort of the windfall of what you've developed over the past couple decades for how to run these large data centers.
Right. Yeah, absolutely. And it is a large investment. And again, with Google, it's not, as you said, it's about interconnect as well. So it's not just about the data centers, but it's about buying that large scale pipe that actually connects all of these things together to give us that high availability and reliability, and making sure that we can move that data around the globe quickly.
Now, we were talking earlier, and you'd mentioned some use cases. It sounded like some people are even using TensorFlow in the cloud directly to provide services. I mean, you can build a model and then build web services on top of it.
That's right. So yeah, so using tools like TensorFlow, we actually have machine learning engine, right? So if you're using TensorFlow and you're abstracting at the right level, using things like estimators, obviously TensorFlow is free, right? You can download that, you can run that on your laptop, you can do the training locally.
Right.
But if you want to do large-scale training, then you have to decide, do I want to set up now my own cluster in order to do this training, or could I use a service? And that's what we're doing with Google Cloud, is essentially you can actually use machine learning engine as a service to help you actually scale out that training and do that training on our platform. And as I said before, soon you'll be able to use things like TPUs, which have extra efficiencies. So TPUs are actually designed to do matrix multiplication really well, right? So tensors, which are just an array of arrays, certainly GPUs have a considerable efficiency over CPUs because they can do things in parallel. But what TPUs give you is that ability to do matrix multiplication.
Right. I'm looking forward to that. Basically, we do a lot of work with large graphs, and so tensors are the magic word of being able to really leverage graphs, because that's the thing that you miss with just linear algebra.
Absolutely.
So, I'm interested in can you give some examples of large use cases here in Southeast Asia where they've been able to leverage the cloud and leverage TensorFlow for drastic improvement?
Yeah, absolutely. So actually one example I can give is in Australia. So there's a company called Maxwell MRI, and they actually built a large machine learning framework to look at prostate cancer. So they're taking these images, they've trained their models using tools like TensorFlow, and they've actually been able to reduce the diagnoses for prostate cancer from a week down to 15 minutes.
Oh, fantastic.
Right, so that's not only a boon for that provider, but think about the effect for patients, right?
Sure,
so
rather families.
Absolutely, right. Rather than having to wait a week, you're waiting for 15 minutes.
Oh, fantastic. And is that largely due to being able to leverage these kinds of technologies, the scale of the cloud?
Absolutely, right. Well, I think it's a number of things. Number one is, they would have already had the data, right? They have years and years of these MRI images with which they have, and they have positive and negative results. This was cancer, this wasn't cancer, this was cancer, this wasn't cancer. So they had that. And TensorFlow then gave them an easy framework in order to create these models, right? So they can create these data flow graphs, they can understand how to do those things, and there are also lots of open source imaging models, right? So you get to stand on the source stand on the shoulders of the giants who've come before you, and you can use those models and create new models and then train those models using something like machine learning engine, which again gives you that broad scale, so you don't have to set up your own TensorFlow cluster, which isn't as easy as people would like, and do that training and then just shut that down, and then you've got your model. And you can do inference in the cloud, right? You can take that model and put that in the cloud, but you can also do that inference on a local machine, or now with TensorFlow Lite, you can actually take a lot of those models and run those on mobile devices or even IoT devices.
Oh,
exactly.
Fantastic. What other types of APIs, though, beyond machine learning and TensorFlow? I imagine there's quite an array.
Yeah. So one of the questions we always get is, where do we get started? We've got a bunch of really fantastic developers, but they're not machine learning people. Right. We don't have data scientists and PhDs on staff in order to create, our own machine learning models. So one of the things that we've done at Google is we've pre-built some models for you. So we've trained some models and we've exposed those models as APIs. Some of the most popular ones are around vision and speech and natural language. So our Cloud Vision API, for example, essentially you can take an image, submit that to our model via an API, and we'll give you back the labels for that. We'll detect things like objects and that kind of thing, but you can also search on more abstract ideas like conference. Is this a photo of a conference? Is the person smiling? We also do things like face detection, so we can actually look at landmarks as well. So if we notice the Eiffel Tower in the background, we can tell you that this is in Paris, even without any sort of geotagging in the image metadata. And actually, one of the great examples that one of our Cloud DevRel people, Sarah Robinson, likes to use is she actually has a photo of the Paris Hotel in Las Vegas, and it knows the difference between that Eiffel Tower and the Eiffel Tower in Paris.
Oh, fantastic.
Yeah. We also have things like the speech API, right? So being able to recognize 110 different languages and actually give you the text output of that. And that's the same sort of technology we're using in things like Google Assistant. And that's available for anyone to use, so they can take that and also do things like dictation if they would like. We also have things like the Natural Language API. So the Natural Language API actually looks at the syntax of a sentence and can actually understand the sentiment, but also the specific entities that are discussed in that. So we can give you automatic Wikipedia links, for example, to specific entities that are discussed, and also sentiment around those specific entities.
Is any of that material or those APIs, is it leveraging, say, knowledge graph to some extent to be able to figure out inference to other resources?
Yeah, absolutely. So it's based on a lot of the same technologies, but these specific models have been more, generalized a bit more so that anybody can use them and call them.
Oh, fantastic. Well, we're actually making use of the video transcription service.
The video intelligence API.
Yeah.
Right, so that's sort of like the vision API to the next level, right? So the video intelligence API goes a step further, I think, than the vision API. Not only does it tag it, it actually tells you sort of where that is in the video. And I think about these companies with like large, video archives that are just sitting there.
Yeah.
And who knows if you might have a small clip of somebody swimming in one. If you wanted to sort of grab all the swimming archives from all of your videos, you could actually run the Cloud Video Intelligence API against those, find those markers, and actually bring those clips up.
Fantastic. We had a meetup last night here, and a couple speakers from Google were showing Magenta out of TensorFlow. So, that stole the show, what you could do with drawing and imagery and recognition. But it really underscored there's a lot of open source available from Google if you want to jump in and start learning how to use this.
Definitely, and also, and also coming out of the community as well. There is a lot out there, and right now I think there's a huge movement as well in terms of bringing out visualizations of those models as well, so you can understand what's going on inside of that black box. Right, as these models get bigger and bigger and bigger, it becomes harder and harder to understand actually what's going on mathematically inside.
Right.
So a lot of tools being developed today are around trying to think about how the AI is thinking about those things.
Oh, interesting. So for model interpretability and accountability, lineage, that kind of thing.
Exactly.
Such important topics here as AI moves out into mainstream business from what we're seeing at the conference, the interpretability. Well, Jay, what's the most common mistake that people make when they're getting into machine learning? What do you see?
Sure. So a lot of people think that machine learning is some sort of a magic thing, that I can just point it at my data, wherever that data is, and it'll just come up with some sort of valuable insight. We really have to sort of work in reverse. What's the question that you want to ask? What are the answers then that you expect? And what's the data that I need in order to get me those answers? Yes, machine learning will create that recipe in order to get you those answers, but it's not going to help you ask the question. Once you figure that out, once you know sort of what data you might need to collect, then you need that good data, right? If you have biased data, you're going to have a biased model. So it's important to sort of understand what's in that data, right? So if you use tools like data prep, where as a data scientist, I don't want to sit here, I don't want to have to like code my my ETL rules, right? Data prep allows me to actually take a look at the histograms of data. I can actually do feature engineering inside of that before the data ever hits that. And as it goes through that ETL, before it gets to my model, all my features and things will be set up. I'll understand the histograms of data. Again, I don't have to do all that work, in Python code just to take a look and do the analysis on the data inside of my notebook.
Oh, fantastic. I mean, one of the big messages out of the conference for businesses is to really leverage machine learning. You have to have your ducks in a row in terms of preparing your data, having your practices, knocking down silos, cleaning up your data, understanding it. So it sounds like really there's a full range there that can be applied out of Google Cloud.
Yeah, absolutely, right? And I think, again, that's where you need to start. It's just what question you want to ask.
Yeah.
Once you sort of get that machine learning life cycle in place, you're just going to be able to ask better and better questions.
Fantastic. Thank you, Jay. Thank you very much.
Thank you.